Roma, Roma, ma, ga, ga, ooh la la, what's your bad romance? Roma, Roma, ma, ga, ga, ooh la la, what's your bad romance?
These three physicists performed the gold foil experiment, in which they bombarded a thin gold foil with fast-moving alpha particles. Alpha particles are positively charged particles that have about 4 times the mass of an hydrogen atom. Geiger and Marsden expected that the alpha particles would pass through the foil with only a slight deflection. We have constructed a human demonstration of the gold foil experiment, in which each of us represent an alpha particle. The green plus sign represents our positive charge.
Subject of physics. Yes, that's a good one. Oh, but the atomic nucleus. Even better! Now, let me tell you where this all began. I am Ernest Marsden. Yes, my good friend Rutherford, Ernest Rutherford, and Hans Geiger. Good men, good men. They gave me my break as a scientist. Yes, and we met at the University of Manchester. Good school, good school. Did a lot of research together, and here we are. I was a professor of physics, yes, my book, in New Zealand, and in 1926, I became New Zealand's leading scientist.
Marsden was here. Well, I'm Hans Geiger. Johannes, to be more exact. In 1902, I began studying physics and mathematics at the University of Erlangen. I then began working with Rutherford and Marsden at the University of Manchester. I just love those guys. Then I worked with them German Nazis. Fun. And then I died.
I am Ernest Rutherford. I'm the father of nuclear physics. I received the Nobel Prize in 1908. But sadly, I died on October 19th, 1937. Hans was here. But nonetheless, I hope you enjoyed this demonstration.
This mattress represents the gold foil. These sheets represent the screen that detects deflected particles. This room represents a lead box containing radioactive source of fast-moving particles.
Alpha particles move at very high speeds. We demonstrate this by moving quickly before we take initial action. We slow down the process for viewer comprehension. The physicists expected all the alpha particles to pass through the gold foil with slight deflection. In this case, most of them did. Observe this particle being released from the lead box containing the radioactive source of the particles. Notice how it travels and passes through the gold foil in a straight line as predicted. But when the physicists checked for the possibility of wide-angle deflections, they were astounded to find that 1 in 8,000 of the particles had been redirected. Rutherford is quoted.
It was as if you had fired a 15-inch artillery shell at a piece of tissue paper, and it came back and hit you.
Why, hello again. In 1911, after pondering our discoveries, my good friend Rutherford reasoned that the rebounded alpha particles must have went through a wacky and wild powerful force within the atom. Rutherford, oh, what a good man. Well, he concluded that this force must occupy a teensy-weensy amount of space, because only a small amount of alpha particles were affected by it. Yes, well, we continued our research together and found that a very densely packed bundle of matter with positive electrically charged particles existed.
Rutherford called this positive bundle of matter the nucleus.
I discovered that the volume of the nucleus was very small in comparison to the total volume of the atom. If the nucleus was a marble per se, the atom would be about the size of a football field. Imagine that!
Roma, Roma, ma, gaga, ooh la la, wild your romance.